Okay. So triangle sum theorem, the sum of the interior angles of any triangle is 180 degrees. So if I add up angle A, B, and C, I should get 180. That's my goal here. Now, the trick to this theorem has a trick. I'm going to go ahead and draw a line right here that's parallel to AC. That's my hint to get into this proof. And since I can't just talk about angle B, I've got angle 1, 2, and 3. Okay. So, what rule do we have that says that there's going to be a line here that's parallel to this line? I've got a line AC. I've got a point B. I'm looking, and I said, hey, there's a line here that's going to be parallel. No, not quite. Parallel postulate ring a bell?
No.
That was fair game last chapter. Parallel postulate says that for every line and a point not on it, there's a line that's parallel. Now, that one we don't use a lot, so I understand not remembering it. There's some I'm not going to understand not remembering. If this line is parallel, can you guys talk to me about angle A and angle 1? Why do they equal the same thing? Alternate interiors. How about angle C and angle 3? They're not same side interior. Was it A and 1? Yeah, C and 3 are also alternate interiors. My goal is to get 2, which is angle B, A and C to add up to 180. Is there 180 degrees already in this problem somewhere? Is there anything up there that's already going to equal 180? A line does, yeah. So that would be angles 1, 2, and 3, right? Would make up a 180.
Yes.
And then I can substitute A for 1, C for 3. That would be A, 2, and C equal 180. That's the interior angles. I'm done. All I got to do is write it down. We're proving that if I add up those 3 angles, I get 180 degrees. I'm proving that the sum of the interior angles of a triangle is 180. Well, because you know it, but you know that it's always going to be true. The point of the proof is to prove beyond a doubt that it always works.
I don't really get why you win. Because if someone's already proven it before, why do we have to prove it? Like, can't we just be like, they've proven it?
Well, that's what we're doing. We're repeating how they proved it. And part of the importance of this is the practice at thought process. This is true. Someone already did come up with this proof. We're not doing anything novel here. I'll have to ask your English teacher what it's like to have to read the same essay over and over again with Scarlet Letter.
Yeah.
Because I don't think you can use that argument with them.
We shouldn't all write the same essay. We should just not write essays.
Just say someone already wrote that essay, we're all done?
Yeah.
So you don't get a grade in English unless you come up with a new thesis that no one else has ever written on the Scarlet Letter. Otherwise, you fail.
Not necessarily.
I like this plan. I'm going to talk to Mr. Walsh later.
I don't have Mr. Walsh, though. You don't know who I have, so... Don't tell her because the girls is not nice.
Okay, interior angles, yep. We'll talk about those later. All right, so given a triangle.
Is that supposed to be an angle symbol?
ABC is a triangle, given. Draw BD parallel to AC. Parallel postulate.
Can we rate that?
Yeah. Now, the one advantage is I don't think we're going to be testing you on the proof on the BA. I think on one of your quizzes I'll give you a fill-in-the-blank version. Normally we say BD is a line parallel as a helper. But technically in the proof, we only start with it's a triangle. We are allowed to draw it, and that's when I reminded you guys about the parallel postulate as part of this. Now from that, this is stuff that we do know. Haley? That's what we're doing right now.
Well, they need to kind of prove it.
If I ask you to prove a test or a quiz, I'll ask you to fill in the blanks. So I'll ask you to recognize the steps. Or I may give you a statement and a reasons bank, and you just have to put them in the right order.
Oh, that's good.
That kind of a thing. Let's see. Now we talked about angles 1 and A. So angle 1 is congruent to angle A. Why? Alternate interior. All that stuff we did with parallel lines last chapter comes into play. In A, we also said that angle 3 was the same for the same rationale. There's a little bit of a jump here. We talked about this being a line. Therefore, these three adding up to 180 degrees. So I'm going to say measure of angle 1 plus measure of angle 2 plus measure of angle 3 equals 180 degrees. I'm going to call that the angle addition postulate. I'll also make a note that we're talking about making a line out of it. And this is where some of the styles of various proofs vary by writer. There's a lot of different ways I can get to this statement involving the various postulates and theorems and definitions we've talked about. Once I've got that, let's go ahead and do some substituting. I'll substitute A for 1, so the measure of angle A. I'll substitute 3 for C, measure of angle C, and 2 and B are the same guy. That was by substitution. I'll put a little note. Note, angle 2 is the same as angle B. And that's what I set out to prove. For all the panic about this, it's really not a bad proof if you remember a couple of tricks. The biggest, I'll always remind you about that parallel line. All you have to do is remember a straight line is 180 degrees. And the properties we talked about last chapter with the alternate interior angles here, alternate interior angles over here, and then a little substitution to round it all out.
How's your coffee?
Coffee's fine. Other questions on that? Yeah. We said here, 1 and A are the same, right? So 1 becomes A. Here we said 3 and C were the same, so 3 becomes C. And 2 and B have always been the same. So there's 2 and B. Stop that.